So bonus fourth video to go ahead and finish out this section. These problems get a little bit more complicated because now we're going to start looking at a composition of inverse trig functions. We're going to put one trig function into another one and see what happens. So we're going to put an inverse into a regular trig function or a regular trig into an inverse. I'm going to try to use some suggestive coloring as we go to really help you understand the information. But remember, with composition, we want to work inside out. So I'm going to start with the innermost of my functions. Here it's the arcsine of 1 over root 2. Now I made 1 over root 2 blue because that represents a ratio. Remember, I put ratios of sides into inverse trig functions. So if I go ahead in my head and let's just figure out what is the arcsine or sine inverse of 1 over root 2, which I can think of that as the sine inverse of root 2 over 2. That works also. I'm going to be in quadrant 1, so what angle in quadrant 1 works? It gives me a root 2 over 2. That's hopefully pretty easy to see now as a 45-degree angle. So I'm going to replace all of that information with a 45-degree angle. So I have the secant of, I'm going to say 45 degrees. I'm just going to work in degrees. I could do it in radians and use pi over 4. So now I have an angle inside of a regular trig function. So up here, I had a ratio right there. Now I have an actual angle. So going way back to our first unit, how do I find the secant of 45 degrees? Well, if I think about, I don't even have to draw a reference triangle. I'm just going to draw a regular triangle because I know it's in quadrant 1. If that's 45, that's 1 root 2. So to find the secant of that, I'm going to go ahead and take my hypotenuse divided by my adjacent. So my final answer is going to be root 2. Notice how we went back to blue because now it's a ratio of sides. It's root 2 over 1 or just root 2. So that's my first problem, working inside out. I started with an inverse and work out to a regular trig function. In example 2, I'm going to start inside this time with a regular trig function. So notice here that I now have an angle and I'm going to work out to an inverse. So the first thing I need to do is figure out what is the sine of pi over 2. Work inside out. Well, if I look at my quadrantals, pi over 2 is right there, 0, 1, cosine, sine. So it looks like the sine is 1. So I take all of this information, that's tangent inverse, I replace it with the number 1. Notice, I used blue because now I am looking at a ratio. It's a ratio of sides. So I need to find the tangent inverse of 1. So tangent inverse is positive in quadrant 1. So if I look at another quick picture, in quadrant 1, if I draw my reference triangle, I have tangent, which is 1 over 1. That makes that root 2. So I'm looking at a 1 root 2, which I know to be 45 degrees. So I go ahead and say, okay, the tangent inverse, my primary answer, is going to be pi over 4. And the reason I use pi over 4, I use radians instead of degrees, is because I started with radians. So my final answer is pi over 4. So if I take the tangent inverse of the sine of pi over 2, I get pi over 4. Notice how I'm flipping back and forth between ratios and angles, step by step working inside out. For example 3, I want to find the sine of the cosecant inverse of negative 2. If I'm putting something into an inverse, it has to be a ratio. So the first thing I need to find is the cosecant inverse of negative 2. So I'm going to write that as the sine inverse, and hopefully we've kind of gotten this down, of negative 1/2. I flip or take the reciprocal of the ratio of sides. When I want to find an inverse, I flip the ratio, and instead of being opposite and hypotenuse, it's hypotenuse and opposite, one or the other. So if I look here, sine is going to be negative in quadrant 4. So when I go ahead and take the sine inverse of negative 1/2, I'm saying what angle in quadrant 4 gives me that value, and I'm going to end up getting, let's see, negative 1/2 is 330 degrees. And again, I'm working in degrees because I can. So in this case, I'm really looking at the sine of, well, 330 degrees, because that's what the cosecant inverse of -2 is. And now I'm dealing with an angle, not a ratio. I got an angle out of my inverse. So now I have to find the sine of 330. I do that by just either looking at my point on my unit circle, or I could draw this little reference triangle down there. That's going to be a 30-degree reference angle. So that's 1, that's 2, that's root 3, and we'll make him negative. As long as I put the 3 inside the square root. Let me draw that again. Square root of 3, there we go. That's 2, that's -1. Looks much better. So if I look at my unit circle, or if I use my reference triangle, the sine is going to end up being -1/2. And I'm back to a ratio of sides as my answer. So the sine of the cosecant inverse of -2 is -1/2. Those were all using exact values. Now I'm going to move on and use the calculator sum. So I'm going to have to use the inverse buttons again, but it doesn't really change anything. It actually makes it a little easier because I can just use the buttons as I go. So I start out here. Again, I'm taking a tangent inverse, so this is still a ratio of sides. So in my calculator, I just take tangent inverse of 44.33, and that's going to give me an 88.7 degree angle. So I'm looking for the cosine of that angle. So again, I took the tangent inverse in my calculator, all of that, and it gave me the angle out. Does it make sense that it's positive? Yes, because I'm taking the inverse tangent of a positive. So I should be up here in quadrant 1. Now when I take the cosine in my calculator, make sure I'm in degree mode of 88.7, it gives me 0.0227. I'll keep a couple of small places. And my answer is a ratio of sides again. The cosine gives me a ratio of sides when I have an angle. So work inside out and just figure out, am I plugging it into an inverse or am I plugging it into a regular function? Second example, if I have the cosecant and secant, it gets a little trickier just in terms of putting things into my calculator. So I'm beginning with a ratio because I'm plugging it into an inverse. Now remember, when I have a ratio, this is -2.4 over 1. So if I want to put it into my calculator, this is really the cosine inverse of, take the reciprocal, 1 over -2.4. And I'm still finding the cosecant of that. I'm just changing things around so that I can actually put it into my calculator. So I take this whole section right here, stick them into my calculator, and I'm going to stay in degrees just because that's easier for me to write down and understand in my head when I'm looking at it quickly. And I end up getting an angle measure of 114.62 degrees. Now does that make sense? Cosine inverse being negative would be right there, and that's where 114.62 degrees is. So I'm really looking for the cosecant of 114.62 degrees. Unfortunately, I don't have a cosecant button on my calculator, and this is where it gets a little bit confusing because I'm going to have to use the sine button. But now I'm going to take the sine, well, let me back up just a little bit. Remember, cosecant of theta equals 1 over the sine of theta. We don't take the reciprocal of the inside, we take the reciprocal of the entire piece. So if I'm going to do this piece, it's 1 over the sine of, I still have an angle at 114.62 degrees. This is where it gets confusing. Up here, let me just circle it quick, up here we took the reciprocal on the inside because we were dealing with a ratio of sides. You take the reciprocal of the ratio. Here, the whole quantity is my reciprocal by definition and by the fact that it represents a ratio of sides. So just try to get those two things kind of straight. So when I plug this into the calculator, 1 divided by the sine of 114.62, I end up getting 1.1. And then I'll just round it off to that. And remember what I just found represents a ratio of sides. Ratio of sides. So the cosecant of the secant inverse of negative 2.4 is 1.1. And the point here is being able to understand and put together a lot of different pieces of what we've done so far. Third and final example, trying to find the cosecant inverse of the secant of an angle. This has to be an angle if I'm going to put it into the secant function. The problem is in my calculator, which I'm using, I can't easily put things in. So I have to remember that the secant of pi over 8, remember secant of theta equals 1 over the cosine of theta. This is really going to become the cosine, 1 over, write it this way, the cosine of pi over 8. And I should go ahead and keep those colors consistent. Let me put that cosine of, we'll keep it green, pi over 8. Notice how we're working in radians, so I'm going to have to switch my calculator over. And this is still the cosecant inverse of this entire quantity. So if I make sure I'm in radians, and I take 1 divided by the cosine of pi over 8, it gives me 1.082. And remember, I'm getting a ratio of sides because I'm plugging in an angle. So I'm looking for the cosecant inverse of 1.082. That's a ratio of sides now because I evaluated a trig function. So if I'm doing cosecant inverse, just remember, whenever I'm doing inverses, I flip the ratio upside down so I can really deal with sine inverse in my calculator. And this ratio was 1.082 over 1, so I'm going to do 1 over 1.082. So sine inverse of 1 divided by 1.082 gives me 1.18. I'll just round off to 2 places. And remember, since I just took an inverse, I'm dealing with an angle. And I wouldn't normally write it, but I'm going to put radians there just so we know. My answer is 1.18 radians, which is an approximate value because I'm not dealing with exact triangles. So the hardest part here is just realizing, like I said, when do I flip the entire function, make it 1 over cosine if I'm dealing with angles, and when am I allowed to go ahead and take the reciprocal of the sides, of the ratio of sides. So you just have to get that idea clear in your head using definitions that we developed early in the year and ones that we just developed. So these questions are a little more difficult and time-consuming, and they also may end up being undefined. But the fact is, we just have to work inside out, take our time, and use all the skills we know.